Today we're going to be discussing topic 13.2, surface area of prisms and pyramids. You will find it on pages 344 and 345 in your Pearson book, so you'll want to take out your book and your notebook and get ready to take notes. Surface area of prisms and pyramids. How can you find the surface area of a polyhedron? Cornelius wants to cover a shoebox with a decorative paper to make a storage box for his photos. How much paper will he need to cover the box? Find the surface area of the shoebox. So when you see the letters SA, they are talking about the surface area, okay? And then there are various formulas for figuring out the surface area of a polyhedron. The book then goes on to give us some examples. One of the ways that they would tell you to do it would be to draw a net of the shoebox or rectangular prism and find the area of each face. Then add the areas to find the surface area of the box. So if you look at the example in the book, you can see where they have drawn the net for the rectangular prism. And then what they did was they established the measurements of each part of the net. So in other words, the surface area for the net would be a combination of this area doubled, this area doubled, and these two surface areas doubled. Okay? So when you look at how they came up with the answer in the book, basically what you have is you have this 60, which they got from this rectangle here, 10 times 60. Then you have another rectangle like that where you have 10 times 60. That's where they got that 60. And then we have the 80, which you can see they got that 80 from that rectangle. We have another 80, which they got from that rectangle. And then we have two more surface areas where we have 6 times 8 is 48. So you have your 48s from there and from there. And then all they did was basically multiply the dimensions, 6 times 8 to get 48, 10 times 8 to get 80, and 10 times 8 to get 80 there, 10 times 6 to get 60. So once you have all of those areas, you can add them up to come up with the surface area of 376 square inches. So Cornelius needs 376 square inches of paper to cover the box. Okay? Now, there are other ways of doing it as well by using a formula. Use a formula to find the total surface area of the shoebox. Notice how the opposite pairs of sides of the shoebox have the same area. In other words, this 80, when we look at the 80, they are talking about 10 times 8. When we get this 48, they're talking about 8 times 6. When they get this 60, they're talking about 10 times 6. And because we have 2 of each of those rectangles, you're going to multiply by 2. So you would have 2 of those, so you would have 10 times 6, but you're going to want to double that. You would have 2 of these, which would be 10 times 8, but you're going to want to double that. All right? and then the same with 8 times 6, but you're going to want to double that. Once you have that, you then take those and you add them together to get your total square inches. Okay? And that's how you would use a formula to come up with surface area. Let's take a look at the triangular prism and how you come up with the surface area for one of those. Okay? So of course, all you have to do is understand that the surface area would be 2 times the area of the base plus the area of the rectangular faces. All right? Now, a lot of times it makes it a lot easier if you take your polyhedron and convert it to the net, and then you just relate the measurements of your polyhedron to the measurements of your net. So we would have a dimension of 12 centimeters there, okay? And then if we were to look at our height, we would have 9 centimeters, and our height would be 9 centimeters here, and we'd have 9 centimeters there and there as well. And then if we were to take a look at our hypotenuse of 15 centimeters, we would identify that on our net as 15, and then we'd have another hypotenuse over here as 15. And then, of course, we would have the length, which would be 18 centimeters, and we would have that identified here, here, and here, and here to help us understand. Okay? Now, remember that this 15 centimeters is also going to be shared by that edge and that line segment as well. So that gives you an idea of how your net would look if you were to unfold the triangular prism. And then all you have to do is take your numbers and plug it in for the area of the base. You'd be working with 9 and 12. And of course, your formula for finding the area of a triangle is 1/2 times 9 times 12. And then you would simply take the measurements for your rectangles and plug them in as well. And you'd figure out each of the dimensions of your rectangle so that you have individual surface areas. And then you would have a surface area of 756 square centimeters. Okay? So you just want to remember that you're breaking everything down into smaller parts that you would be working with in order to come up with the area. And just remember that you're going to match up measurements with your net to your surface area. Let's take a look at finding the area of a square pyramid. Now in this case, they're saying the surface area of a square pyramid is the area of the base plus the number of triangular faces times the area of one triangular face. All right? So in this case, what we have here, all right, is a situation where we have the area of the base, and over here, if we look at this, we have 3 inches. It is the base of 3 inches by 3 inches. So we essentially have a square. And so we would have 3 times 3, which is 9. So that has an area of 3 square inches. Then we want to figure out the area of the triangular faces. And in order to do that, we would take our triangles, which have a 3-inch base and a 5-inch height. And so we would simply take 1/2 times 3 times 5, and then we would get our area of 7.5, or 7 5/10, which we would multiply by 4, because you have 4 of those. 1, 2, 3, and 4. and each one of those triangles has an area of 7 5/10. Once we've established that, we can then come up with our overall surface area, which is 39 square inches. So the important thing to remember is you find the area of the base, and then you find the surface area of one triangle, and then you take that surface area and you multiply it by 4. And that would give you your total surface area if you added those together. Alright? And that's how you would solve a problem for a square pyramid. Okay? So that gives you some idea of how you would do that. Okay, let's take a look at some example problems. See if you can solve these problems. Pause your video as you work. Okay, number 1, the candle shown is shaped like a cube. Draw a net for the candle. Well, you could have drawn your net several different ways. Here's pretty much the traditional way of drawing a net for a cube. What is true about all the faces of a cube? Well, all the faces of a cube are congruent squares. So the answer to A is all congruent squares. Then they ask you to find the surface area of the candle. Well, we know that all the faces are going to be congruent squares. We know that if they're squares, that means they measure length and width of 2. So in other words, all we have to do is multiply 2 times 2 to get 4 for each face of our cube. And then we know that we have a total of 6 faces, so then we'd have to multiply 6 times 4 to get 24 square inches. So mathematically, it would be multiplying 2 times 2, which would give you the surface area of one face, and then multiply by 6 to give you the surface area of the total cube. Okay? Use a formula to find the surface area of this rectangular prism. Okay, one of the first things that I like to suggest that students do in a situation like this is identify your width, your length, and your height. And then all you have to do is establish a formula to find the surface area, which would be 2 times your length times the width, 2 times the width times the height, and 2 times the length times the height. So in order to solve that problem, you would just plug in your numbers and you'd get the following values. Okay? So if you were to take this, you would have 2 times the length of 5, because here's our length of 5, times the width of 10. If you do the math, you would then have 10 times 10, and then you would have 100. So that's where we came up with 100. If you wanted to figure out how you came up with the next measurement of 300, what you would have for this one would be 2 times the width of 10 times the height of 15, and then you multiply out using the order of operations to get 20 times 15, and then, 2 times 10 to get 20 times 15, and then 20 times 15 would be 300. So that's how you came up with your 300. Then what you would do is you'd multiply to find your final surface area for the 2 rectangles remaining, and you would have 2 times 5, a length of 5, times a height of 15, and you would multiply this out to have 2 times 5 is 10, and that would be multiplying by 15 to get your area, which would be 150 for that rectangle. And so your 150 is your next answer. And you add all those together to get 550. Okay? So just know that when they're talking about the length times the width for that first part, they're talking about that measurement right there. Okay? Then when they're talking about the 300, the width times the height, they're talking about that measurement right there. And then when they're talking about the length times the height to get that measurement, you're talking about this area right there. Okay? That right there. Number 6. See if you can solve number 6. What is the shape of the base of a square pyramid? Draw the net of this figure. Well, the base is going to be a square. The shape of the base is a square. And your net will traditionally look like this. The base is a square. It is a pyramid, so all the other faces will be congruent triangles. So your net is going to look something like that, okay? You have your square base and then a triangle for each side of the square. Let's try this one. Number 8. Okay. Let's see how you did. If each side of the base of the square pyramid is 8 inches, that's important information. The base of the square pyramid is 8 inches, and the height of each triangular face, is 10 inches. What is the surface area of the square pyramid? Well, one of the things that I like to do is draw out the net right away. And what we know is the base of the square, or the base of the square pyramid's base, is going to be 8 by 8. So that's an 8 by 8 square. Okay? And then we know that the height of the triangle is going to be 10 inches. So now we can figure out the area of the triangle. All right? So in this case, we would use the formula for the surface area as follows. Okay? And we would do the math like so. Okay? First of all, the area of the square would be 8 times 8, which is 64. So we've established that and got that out of the way. Now what we're going to do is we're going to find the area of one triangle. So we would use our formula, which is in parentheses of 1/2 times the base of 8 and the height of 10, and we simply do our math now. Half of 8, or 1/2 times 8, gives us 4. So now we have 4 times 10 inside parentheses. 4 times 10 is 40. So now we have 4 times 40, which is 160. And you can see that we now have the two numbers for our polyhedron areas. We have our 64 and our 160. We add them up and we get 224 square inches. Okay? And that's all based on finding the dimensions of our base first and then finding the surface area of our triangle. So we find our surface area, and then we find our surface area and multiply by 4. All right? If you have any further questions, you can see your teacher. You can watch the Pearson Realize video or ask your parents for some help.